on absolutely scientific lines. It will go as a very important event in the history of conservation of Indian art and Indian uh, culture and Indian temples. Unfortunately, his work, I think, is not much known in this part of the country, where we are losing almost every day some of the ancient temples and ancient sculpture. Um, his work I happened to see in Hyderabad recently, where he projected the scientific nature of conserving ancient temple in ruins. And I was amazed at the way he has approached the subject. The scientific preparation before going and touching a monument in ruins, and how he could reconstruct the whole thing and see that it could last another 1,000 years. And I am also very particular that this must be shown in Delhi, in the capital of India, to show how we have enough scientists, we have enough talents in this part of the country to do such excellent work. Only please contact them and utilize their services and experience for preservation of temples. I know that the UNESCO experts who were invited to advise the government of Tamil Nadu for repairing the Sri Ranganatha temple in almost 1968-69. In their report, they have given an excellent report on conservation of ancient temple, basic principles, what you have to do, how you have to approach it. And in that report, they said that you have enough talent in this country who can do that. You please only contact them. There is no need for us from UNESCO to come here all the way and advise you. They are there. Only thing is you give them the freedom and what you call the enough support so that they can do absolutely scientific conservation. And exactly now we do the opposite of what has been done, what has been recommended by the UNESCO in Sri Ranganatha temple at Sri Rangam. As I am reminded of one important scientific project that was taken up by one of the Nayaks of Tanjore, Sri Vijaya Raghunatha Nayak. In his court, he heard that there are more interpretation of ragas, classical ragas, different people defining one particular raga in a different way. And so what he did was, he assembled all the top singers of Tamil Nadu at that time, also in Andhra, and asked them to sing each and every raga. And in the sadhas, he said whether this is correct or that is correct. And he says why he is attempting this, so that at least the future generation can understand how to sing a particular raga. There is a book called Sangeeta Sudha, which was written by Raghunath Nayak in association with Govinda Dikshita, his minister. Unfortunately, one part of that manuscript has not been found. It also contained a chapter on dance, Natya. Only the music part has been preserved in the what you call Saraswati Mahal Library at Tanjore. So they have thought about scientific method of listening to different ideas, different concepts, and experience is utilized for preserving it for posterity. And we have Pandurangarao, who has done outstanding work on Warangal temple. Warangal we have beautiful inscriptions. I won't go into that. Beautiful inscriptions at Warangal, which served as the converging point of so many artists, musicians from Bengal, instrumental musicians from Karnataka, vocal musicians from southern part of India, Tamil Nadu. All of them were invited and they were given support, and that is how in the Warangal Kakatiya capital of Warangal, they developed music and dance. And you know that the most important one by Jaya Senapati Nrityaratnavali, it is there, it has been published, it has been translated. But what is amazing is that almost at the same time, sculptures were carved in that Warangal temple and also nearby Ramappa temple. And that part of it, he has done a wonderful job. We thank you, sir, on behalf of all the scientists of this country for doing and putting conservation on absolute scientific line. I am very happy you could come. And we are very happy and thankful to Ramakrishnan for agreeing to organize this. And I am glad that we have come, and this has to be shown to all the people compulsorily. And I think we must have one in Indian Institute of Science Technology. And all these, those who want to know what is conservation, is there a science behind it, or whether the agamic pandits and Vastu pandits were able to give us a line how to preserve it. And that is not against modern science. That's what has been proved by Mr. Pandurangarao. I am very happy you are here, sir. Please do enlighten us on what you have done at Warangal. Thank you very much. I want to present a small book.
Oh, yes.
I want to present a small book on grounds of India. And he has given me his book. It's an excellent book on the Kakatiya contribution in the temple. Wonderful book. But unfortunately, he tells me all the copies are out now.
No, I brought one copy to our Ramakrishnan, sir.
So I am very happy to present this
Thank
copy.
you, thank you, thank you, thank you. Sabhaya Namaha. I am so happy and delighted to be here, especially with a beautiful introduction of our Guruji. In fact, he's more than that. Padma Bhushan, Vidya Vasaspati, Kalai Mamanai, Dr.R Nagaswamy garu. We really, I am beholden to you for all that you have said. This all His own grace, the God's grace, that is making us to move forward with such small things. I am really grateful to Ramakrishnan garu for giving us an excellent opportunity to present some of our small works. I retired from NIT, National Institute of Technology, Warangal, more than 2 decades back. And my aim is to continue to propagate the concepts of conservation, how we are protecting. I am not a historian. I am a geotechnical engineer. It so happened in 1980s when I was a professor in REC. In those days, it is known as REC, Regional Engineering College. It so happened that my REC in Warangal was first REC in India. Pandit Nehru, the then Prime Minister, came to Warangal on 10th October 1959, and he laid the foundation, first REC. Then other RECs like REC Trichy in Tamil Nadu, REC Surathkal in Karnataka, then Calicut in Kerala, they came up. So we are proud that I am from first REC of India. And I had a big project from Archaeological Survey of India way back in 1980s. And we have done a lot of investigations, what we call geotechnical appraisal and evaluation of Kakatiya monuments. You know, the great Kakatiyas have ruled for over 300 years, way back in 11th to 14th centuries, and left us an excellent indelible mark of their great empire. They were magnificent and benevolent rulers. They have created mighty irrigation projects and magnificent rock temples. So their concept is tank, temple, and township. So they create a tank, a beautiful water bodies. And then to commemorate the water body, they have created a temple. Temple is not only for worship, it's a place of administration and whatnot. And then they created a township around it. So tank, temple, and township, the 3T concept they have followed. And they were very, very benevolent rulers. And we have identified through satellite imageries 46,000 tanks in Telangana. 46,000 tanks in Telangana. Some of them have disappeared due to occupation and whatnot. I advise the government of Telangana on Mission Kakatiya, the flagship program of government of Telangana, through remote sensing. So we had extraordinary remote sensing data way back in 1980s from US satellite, what we call Landsat, and then French satellite spot data and all those things. So we were doing such a beautiful work of evaluating the Kakatiya monuments, and then the 1,000-pillar temple, the kalyana mandapam of 1,000-pillar temple was in great shambles and collapsed. And then we will see what, Amma, can you, how do we?
Slideshow.
Next is, how do we go?
You have to press this button.
This one? Okay, next. Priya, how to go back? Right. This is forward, okay? This is, right. So this is renovation and the restoration of Kakatiya monuments of Warangal. In that we have included 3 important components: the 1,000-pillar temple, the Warangal fort, and the Ramappa temple. Now these 3 are great monuments, and unfortunately none of them are in the World Heritage List under UNESCO. Now we are taking forward the Ramappa temple into World Heritage. I prepared the dossier along with my colleagues, and last year we tried, and before last year also we tried, and it went up to UNESCO. But this year again we are trying. We got number 2. Only they accept only 1 monument in a year for UNESCO. So we are always number 2. Now we hope we will become number 1 in this. So this is the geotechnical appraisal on evaluation of Kakatiya monuments, 24th, 25th February 1991. Now you can see Murthy, you can see Venkateshwara there. This is me in 1991. Indication, okay, doesn't matter. This is me in 1991. This is the Director General of Archaeological Survey of India. First Director General ever to visit Warangal at my invitation. So because I had a big project for over 10 years, and we made out that particular project, the book is here. I brought the book. So this is the book which I prepared way back in 1991. So this is Geotechnical Appraisal and Evaluation of Kakatiya Monuments, for which I invited the then Director General, Dr. M.C. Joshi, to release this book and take the findings. Now this book is something like a Bible in the restoration of the monuments. Now this book consists of 4 research scholars, 4 professors. Professor Raghavachari, Professor Babu Shankar, Professor Somayazulu, and Professor Pandurangarao. I am the coordinator. This project is sanctioned on my name. Unfortunately, I lost all 3 of them. I am only there to carry on the mantle. It's God's wish. Still, I am pursuing the process of continuing the activity. So this is one of our very great historic events. The other 2, this is my another friend, Professor Venkateshwara Rao, and another friend, Professor Shastri. We're all from Department of Civil Engineering. My specialty is in geoengineering and engineering geology. So geotechnical aspects I was dealing. So we have been doing a lot of research activities, which include geophysical investigations through electrical resistivity methods and seismic methods. We send current into the ground and evaluate the subsurface. Similarly, we send seismic waves. We generate seismic waves and allow them to be transmitted through the layers and evaluate the subsurface. And then we drill boreholes and collect samples and integrate all of them together and make the cross sections of the profile of that particular area. Now, that's how we have investigated the entire region of all the 3 important monuments. Now, this is our 1,000-pillar temple, and ma'am is so excited because she lived there. She has spent her younger days in 1,000-pillar temple. Now you could see here the 1,000-pillar temple with Nandi, a great, beautiful Nandi, and there is a prop there. There is a prop, and this is the prop, a column which was created by Dr. Ejdani, the then director of Nizam Archaeological Survey. And this is the roof beam. The roof beam was broken into 2 pieces. To maintain that, he has put a prop.
1 second, sir. Help you.
Good, thank you. Right. I think, am I abstracting? No. No. Right. Thank you. So you could see here the roof beam has become 2 pieces. It broke. The roof beam broke into 2 pieces. So Dr. Ejdani has put a prop. Had he not put that pillar, the whole structure would have collapsed. Now what we have done is, now we have done scaffolding and transmitted the load on this scaffolding and then brought down the beams, the broken beam. Thank you. And brought down the broken beam to the ground level. This is the broken beam. You could see here. The roof beam is broken into 2 pieces. And then we brought down to the ground level those 2 pieces. And then we cut the groove inside. So a big groove was cut, and there is an iron girder. This is the iron girder, you could see. So these are the 2 pieces of the roof beam, and we have cut a groove, and this iron girder is inserted into the groove and then fixed with epoxy resin. And then we have created a thin slice of granite on the top. Now you see we have put the girder inside and filled it with epoxy resin and then replaced it back to the roof level. Now this is one of our beautiful contributions of restoration, and this structure would be there forever, as long as the rocks permit. So similarly, we have the beautiful 1,000-pillar temple, and the locally available rock, they have used it. The local available rock is granite and the dolerite, black granite, the hardest rock in the world. So they have carved all these great load-bearing columns in black rock, in dolerite. So this is how the columns of the 1,000-pillar temple. Beautiful, shiny, mirror-like polish. The roof, there were leakages. We have attended the roof with lime mortar. So we prepare the lime by taking the fresh lime and then grinding it along with black jaggery and then soap nut, karakaya, we call it as karakaya, and then mix them together and go for sealing. So we are doing that on the roof level. So I go up and check up what's happening and all that. So this is before and after. This is what we call pradakshana pada. We'll go around sanctum sanctorum Pradakshinapada, before, after. So this is the great Nandi, which is carved out of black granite, single monolithic rock, and they have cut the ears. You can see they have cut off the ears, and see the level of ornamentation, extraordinary ornamentation on the hardest rock. So this is the Sasanam. So this is the Koneru. In the northeast corner, they have a Koneru, and this is one of the best examples of how Kakatiyas have utilized both surface water and groundwater conjunctively. In 1970, 69, 70, 72, there was a big drought, such a huge drought, and there was no water in Warangal. There were no reservoirs at that time. The whole town went off. Mr. P.K. Dauraswamy was the collector. I was referring to Ramakrishna Garu. He was the collector of Warangal. In fact, he identified me a couple of years back, 2 years back, when I made a presentation of Nitya Ratnavali, which I will show you. Then he identified me, and he came to the dais and said, Professor Garu, I still remember your contributions to the people of Warangal in drinking water problems. So, at that time, this well, the Koneru, supplied water to a large number of people in that area, where I was advisor. So this is the Koneru. So this is our great, the Kalyana mandapam of 1,000 pillar temple. Now you could see they're all in shambles. You have wonderful columns. You could see the white patches. We have numbered them. Every bit, every piece has been numbered. And you could see the props. You could see the props, and you could see the retaining wall here. It's all done by great Yazdani, almost 150 years back. So that's how the structure is like this. This is done by 1163 by great Kakatiyas. So this is how we have planned for the foundations. So these are 132 major columns. These are all locations for the columns. 132 major columns are there, out of which 119 are available, 13 are missing. So we are now done that from the existing local available rock. Now this is how the foundations have been planned. So this is the ground level. This is ground level, and there are 7 layers, what we call Pradakshinapada. We go around the temple. And then we have the Kakshasana, and then this is the floor level of the Kalyana Mandapam. So all this is filled by great sand. The Kakatiyas have adopted what we call sandbox technology. So wherever they want to build a structure, they identify the area, maybe 40 meter by 40 meter, and remove the entire material up to a depth of 2 to 3 meters, and fill it back, the pit, with sand, and then construct the structure. Now, as long as the sand is confined in the box, it takes maximum strength, maximum load. The moment there is a loss of confined sand from the sand box, there will be settlement. The settlement is uneven, differential settlement. So the structure collapses. This is exactly what happened in the case of Kalyana Mandapam. We have identified through our satellite data a major fault, major lineament passing through the Kalyana Mandapam along the Koneru. Now that's the reason why Koneru is having such a beautiful groundwater resource. So they've identified the major fractures where the groundwater flows. We have strengthened, we have improved the bearing capacity of the foundations by taking care of granular piles. These are all granular piles up to the depth of bedrock, 7 to 8 meters below the ground level. Below the ground. This is the ground level. This is the floor level of the structure. And then this is the Pradakshinapada, Kakshasana, and the various columns. Now you could see here, these are all the props created by great Yazdani. And this is the retaining wall on the northeast corner, where the fracture is passing through the northeast corner. So this was done by lime mortar. And it has become a hell of a job for us to break the lime mortar. It was so hard. Fortunately, the lime gets its strength from time to time. The cement loses its strength from time to time. So the life of cement is limited, about 100 years. So at one point of time, number of institutions came forward that they would build this structure. One such company is Navayuga Construction Company. So they were prepared to do the entire foundations, which cost about 1.5 crore, with cement. They wanted to go for raft foundations with cement. Then me and my other colleagues from Archaeological Survey of India, Mr. Jamwal, he was the Director of Conservation, he's a very great personality, very recently retired. So we deliberated on it for a couple of months, and finally we took a decision. Cement shall not be used in the construction at all. We use only lime. So they never agreed to come forward with lime mortar. So we have dispensed with it and took up on our own the entire construction. Now you could see how badly the columns have undergone settlement, and this is one prop, and all of them in shambles, and we were afraid of going inside. You could see that. Now we started removing them one by one. So these are all door jambs. Door jambs, very carefully, we have started removing them, and we have transported to a place nearby, and you could see the numbers. You see, every bit has been very carefully marked. We have more than about 20,000 pieces. And you could see them. So every bit is identified. We don't want to lose even a small piece. We go for mending. Now you see, we have removed the whole structure. So this is the last layer.
So this is the ground level?
Ground level.
Oh,
Last layer.
Oh.
And this is all sand. This is all sand. This is the shed for Nandi.
The original sand?
Original sand, completely original sand. Now you can see very clearly, and we removed the sand.
Oh.
Now you see the big pit. We have removed the sand and stored it at the same place where we have stored our pieces.
Okay.
And then obviously water seeps in. And pit. So there was a lot of commotion. So something has come, some divine power has come, the water has come, and whatnot. And at this point of time, the press made a hue and cry, and these fellows have destroyed our kalyana, mandapam, and whatnot. And it became a big, and I became the target. And finally, High Court, Honorable High Court, Chief Justice took it subamoto and then called us. Then we went to Honorable Chief Justice of Andhra Pradesh High Court, and then we said, we are the custodians. The Archaeological Survey of India has given us the permission. The Director General visited in 91. He gave us the permission. We showed him the totally dilapidated structure, and you can't even go. If you leave like that, it becomes in ruins. So then we gave it in writing that we are the custodians, we will restore it back. So that's how we could convince the Honorable High Court and then the local press.
How did the water come?
No, this is seepage. Just a seepage.
It is only 2-3 meters only, no?
There is a big tank there. There is a big tank known as Badri tank. So there is a lot of, in the normal rainy season, the water level is high. The water table is high. And this is a good water-bearing aquifer. Now we have, in the pit, we have gone in for boreholes. We have drilled boreholes to know to what depth the rock comes, what type of layers we get in it. So you could see here the core samples and the type of material we get in the boring process. So this is the still pit. Now you could see the pit. Again, we have refilled the sand and then being consolidated with a 10-ton vibratory roller. Sand gets consolidated with vibrations. So we have done that vibration. The same sand, we brought the same sand back and filled it. and then the water get trapped in it. So we would like to release the water pressure, and we drilled a few holes and then established the density of compaction. So we have taken samples and conducted tests in the laboratory, NIT, REC, and then we are satisfied that the sand has been properly consolidated. And you can see the ram, you can see the vibratory roller, and then we have tested. This is me. I went to Lord Venkateswara to give my hair because there are so many problems coming one after another. And so Lord Venkateswara was kind enough to give us the clearance.
With so much scientific, you have done all these things. How they would have done all these things?
They must have followed all these things in a different way. Undoubtedly, they are great people. And there is no second thought about it. We feel that we are great, but certainly they are greater. And the very fact that we are able to see them after 1,000 years itself is a testimony for their engineering skills. In fact, in our World Heritage... So?
No. Knowledge is not the...
It is not somebody's domain. It's
I'm not excited with the slabs. I'm excited about the sand. The sand that was under.
Yes.
Sir, where from they get the sand? It is a rocky area, no?
No, local, Godavari is nearby. Godavari is 100 kilometers from there.
Yes.
They get water. And, sand is available in small rivulets also. There's not a big problem to get sand. So we have done a number of tests to establish the bearing capacity of the soil, because once we build the structure, again it should not undergo differential settlement. So we started marking the layers. And these are the grids which we have created for strengthening the foundations through granular piles. Normally we use piles. We use pile foundations to take more load. We do it with RCC. We drill a hole, insert our iron rods, and then pour cement and make piles. Unlike that, these are all dry piles. We drill, this pile is about nearly a meter dia pile, and then drive a hole up to the bedrock, about 7 to 8 meters, and then remove the sand and fill it with with sand and gravel. And fill it with sand and gravel and ram it with 10-ton hammer. 10-ton hammer. It's like a pile. Instead of RCC pile, we have a granular pile, granules of metal and sand only. So that's how we have done about roughly 360 piles in that area to improve the bearing capacity of foundation. Now you see the drilling is in progress.
Professor, I have a question.
Yes.
When you are doing so many piles, when you are ramming one pile, other pile will not move up that original position?
No. We have taken care that we don't do immediately side by side. Side by side. We ram one here and go to the another place which will not interfere. And like that, we have a grid pattern of ramming with 10-ton hammer. You go on hammering it with 1-ton hammer, 1-ton hammer. Now you could see the slush and all that. Now we are drilling holes. I'll show you later. This is again, what we have done is, we have seen that there is a major fracture and the sand is escaping through the fracture. Now we wanted the whole process to be modernized, keeping the traditional technology. So we have drilled holes, another 150 holes, and then injected lime into the foundation, to make the sand into a sandstone. Now it became one monolithic rock with sandstone. Irrespective of the external influences, the material does not leak out. That is how the drilling is in progress. So we are now discussing. So this is me and my other colleagues, and he is in charge of 1,000 Pillar Temple. And he has designed the granular piles. Mr. Ramappa, one of my old student. Now, after we have done this entire exercise, we wanted to know how much the load it takes. It's just not a casual information. So what we do is we take a plate bearing test. We transfer the entire load onto a small plate, 1 foot by 1 foot, and load it. These are all the loads over that 1 foot square area. Now you see, we are now, this is the loading, loading platform, and on the above we have the load, and this is me and my other colleagues. We are sitting right beneath. If something happens to the load, off. We will be off. So God is there always with us. So we have completed the test, and we have gone up to 50 tons per square meter. We have gone up to 50 tons per square meter, and we found still it is not yielding. So we were afraid there's enough. For us, 20 tons is more than sufficient. So we have gone up to 40, 50 tons. So we were satisfied that our pile foundation, granular pile foundations, were very successful, and there is no scope for future settlement. Now these are the piles. You can see each is a granular pile. Then we have done for about 300 granular piles. This is half a meter dia, sometimes 1 meter, depending on the requirements. Then we started giving in for a coarse metal over the piles, then consolidating the piles with the vibratory roller, then marking the temple on the ground. Then what we have done is we have gone in for 1 meter width lime mortar all round. 1 meter lime mortar all round, lime mortar, so that this doesn't skid. Then ramming it. Now we have the complete first layer to be put on that. So we have put the first rock, first stone. We are doing the Bhumi Puja. This is me and my other colleagues, and he is the chief priest, Upendra Sharma. So we are laying the first stone after complete stabilizing the foundations. So we laid the first stone and marked the external things. Then we are bringing the stones from our stockyard one by one, and started laying the first layer. You could see the first layer. Now first layer is completed. And this is our stapati. And here the Kakatiyas have done an excellent job of integrating all these stones through iron dowels. The iron got rusted. So we have removed that iron and replaced it with stainless steel dowels. So the life of stainless steel is pretty large. And the real technology of Kakatiyas is, even if there are earthquakes of a moderate intensity, the structure does not fail. It vibrates, just like our RCC columns. Now we are doing RCC columns with integrated network. At that time, they have done this exercise. In fact, these structures have undergone earthquakes of moderate intensity, maybe 4, 4.5. And similarly, Ramappa also had undergone earthquakes. So this type of integration has helped to create a monolithic approach to the monument. So you can see. You can see the stainless steel dowels. So we have integrated all of them by removing the iron dowels. Now second layer had come. Now you can see the difference. This is the iron got rusted, and we have replaced it with stainless steel. Now before and after. Now this is our team from Delhi. He is our priest, and this is me, and this is the Director of Conservation. He recently retired. He is the Additional Director General from ASI Delhi. our Stapati trying to meddle with the. Now we have come up to the Pradakshana Pada, 7 layers. You can count from them. One more video. 1, 2, 3. This is the 4th, 5th, 6th, 7th, and then there are small openings. You know, the Kakatiyas have taken care of the openings by filling with sand, and now we have taken up that task and filling it with lime mortar. Lime mortar. Now he is trying to adjust. You have to adjust it everywhere. And Kakatiyas, you know, normally any monument, they do it very beautifully on all the 1, 2, 3, 4, 5 sides. They leave the lower one in a very bad shape. So that's the reason why they have selected sand as the filling material for adjustments. Now what we have done is, instead of sand filling, we have taken up lime mortar. Now in the openings, we pump lime into those crevices. Now before and after. Now this is the floor level. Now we started building the walls. Now walls are cavity walls. It's not a single wall. You have 2 leaves, the outer leaf and the inner leaf. Now in between you have a vacant space. Now they have filled it with muck. Now whereas here we have done it with lime mortar, so that it becomes an integral part. Now these are the walls. You can see the outer leaf, the inner leaf, and the cavity inside. Now this has helped in maintaining something like air conditioning inside the sanctum sanctorum. You can see the beautiful cavity walls. Now this is the Pradakshana Pada and this is the Kakshasana. This is 7 layers, this is 5 layers. And then the walls. Now we started putting the pillars. Pillars are being positioned there. So this is our Stapati. In fact, I wanted Stapati also to come. He said he will come. He stays in Tirupati. He is one of our greatest personalities. Now you have seen the columns. The columns, this is the ground and 7 layers, Pradakshana Pada, and then the Kakshasana, and then the wall, cavity wall, and then the pillars. Now roof beams, the beams at the roof level, they are being put there. Now the cavity in between, the outer leaf is filled with lime mortar. Now these are the capitals. Now different types of capitals. You have square, round, plus, and whatnot. So these capitals are being fixed there. So one capital. Now you could see here, this capital has place for 3 columns. Now this was broken into 2 pieces. We don't want to leave them as it is. So we have mended them by drilling holes on either side and insert stainless steel rods and fix it with epoxy resin. I'll show you. And this is at the roof level. So you can see the roof beams. So these roof beams are interconnected in such a way they are integrated. You have the normal beams and then the cross beams. So thereby they get high stability. Now you can see here, this beam has 2 cross beams here. So they are all interwoven. Now you can see here on the roof level, these are the cross beams. No, this is only just leveling the. Now you can see here the 3 crowns. This is broken into 2 pieces. You can see one piece and another piece. Our Stapati is trying to adjust it. Now this is the broken piece. So we have drilled holes on either side, insert stainless steel rods, 6 mm, 8M, depending on the requirements. And then fix it with epoxy resin, and then take it there and keep it. And at the ground level, we have not filled with sand, we have done with RR masonry, random rubble masonry with lime. So this is our lime manufacturing unit. And these are the pillars which were missing, so we are carving them at the site from the local available granite. So these are some roof, floor beams and roof beams. So this is the carved one. Now this is how it looks. Now he is the in charge, Mr. Shivakumar. Now this is how we have brought it to the roof level. Now for the last 1 year the work has stopped due to various reasons. We are trying to revive it as early as possible. So this is one about 1,000 pillar temple, how we are restoring it without using cement, iron and concrete, without 1 millimeter variation, without 1 millimeter variation. Suppose if there is a variation, by chance if Stapati wants to accelerate it, put it there, the next layer he will not be able to do it. Because they are so interwoven and they are all integrated systems. So you cannot hasten it up. So by virtue of their technology, we cannot make a mistake. Even if we make a mistake, again we have to retreat back. So that's how the great Kakatiyas have done this wonderful job. We are trying to restore. So they have given us for 1,000 years. Our aim is to see that our posterity will enjoy at least for 1,000 years. So this is on 1,000 pillar temple. Now we can see the Ramappa temple, which we have. I can take another.
Please carry on. No hurry. Carry.
Right. So geotechnical evaluation of Ramappa temple. You know, Ramappa is one of our finest jewels of this era. Why? Because this Sekara, you could see the Sekara in 1980s, the Sekara was with full bricks. I'll show you a little later. They were all bricks. These bricks float on water. I don't think you have ever heard of it. In fact, Ramappa temple was given to us for adaptation for our Kakatiya Heritage Trust. Last month I went to Delhi to receive the letter of intent from Honorable Minister of Tourism. Tourism, Culture and Archaeological Survey of India. Together they have formulated adopt a monument, not only for us but throughout India. So our Kakatiya Heritage Trust, I went on behalf of the trust and I received a letter of intent. Then we made a vision document. They wanted us to give us the vision for 5 years, how we are going to maintain the monument. So we have given a vision document for 5 crores for 5 years. So GVK Airport, so they were our competitors. But fortunately, they have identified us as the real custodians and they gave it to us. So we are going to maintain the Ramappa temple, and the brick is of great significance because when people used to go there, they take one brick and put it in. There used to be a channel there, irrigation channel. They put in the irrigation channel and walk through when it is floating. Like when we are children, we used to play with the boats, the paper boats, and put into the water. Then we realized that this is going to be a danger. And then we have suggested, I have suggested, and then we have gone in for lime plaster. So now we have, no brick is visible. The whole thing is beautifully lime plastered. And again, there was a criticism at that time, you are spoiling the monument. But had we not done this, maybe half of the Sekara would have disappeared through this process. Now this is the beautiful view. So this is the lake. We have a beautiful lake there, Ramappa Lake, and then the adjoining parts. So the zone. This is, we have sent it to UNESCO for recognized as World Heritage Monument. A part of it we have borrowed it. Now this is the panoramic view. So this is the great Ramappa temple. Now you could see here the columns, the props. So they're all, it's a beautiful rock cantilever. You know, we have cantilevers of 5 meters, 6 meters. Now they have done a similar exercise in rock cantilever of 4 to 3 to 5 meters cantilever. Now how will the rock support itself? So they have gone in for an excellent innovation of putting brackets, putting a bracket to support the cantilever. Instead of leaving the bracket dummy, they have created a beautiful Nagini, a very well exuberant Nagini they have created. So this is rock cantilever. So there was some problems, so it's likely to collapse. So they have same Ejdani has done this exercise. So again same. Now this is the book which I have shown you, Geotechnical Appraisal of Kakatiya Monuments. This is the Ramappa Temple, the Thousand Pillar Temple, and the Warangal Fort. Way back in 1980s, I had a project from ASI Delhi in 1980 to 83. We have done for 10 years of exercise, 10 years of investigations. We have seen those investigations, the main temple. You see the borehole analysis. So these are the bores which we have done and extracted the samples for direct observation and then did seismic surveys and electrical resistivity surveys to confirm the subsurface performance, subsurface behavior. Various locks, different places. So this is one seismic survey. So we create seismic waves and allow them to be transmitted and pick up the waves and evaluate the subsurface up to a depth of about 10 to 12 meters. So this is the great Ramappa Lake, a man-made lake of 3.2 MCFT, million cubic feet. It's one of the biggest lakes. We have another Pakal Lake, it's about 3.5 million cubic TMC, 1,000 million cubic feet, TMC, we call them a TMC. Normally most of the lakes are very small, half a TMC or 1/4 TMC. But these are all great lakes, and the Kakatiyas have done it 1,000 years back. Even now they are giving us food and drinking water. So this is how the floor beam failed. You can see the failure. It's a continuous floor beam. It has failed due to excessive, and this is the type of soils we have. We have done complete soil investigations, their properties and whatnot. So various properties. And this is how the external looks like. Now the rock cantilever. So this is the rock cantilever. They have created a bracket, and these are the beautifully well-carved bracket figures, where the Nitya Ratnavali has emerged out of it. So Sanctum Sanctorum, Lord Shiva. So Pradakshana Pada, Kakshasana, and the floor level. This is the floor level. You must have heard of Dr. Nataraja Ramakrishna. Nataraja Ramakrishna. He's a great... Andhra Natyamu. So he has worked there and created Perini Sivatandam. Perini Sivatandam out of the various dance poses. And it's one of the male, highly male Chavaline dance form with ferocious activity, and that is supposed to have been performed before the people go for a war. So you can see these are all sandstone. Now the local available rock is sandstone, like our red sandstone of Red Fort. Red Fort, the same type of period. the same rock, sandstone, they have used it, and see the extraordinary carvings there. So we have done total lime plastering. Now you can see how it was. This was a 1914 picture. It was like this even in 1980s. Such a bad shape. So we have removed and then we made like that. So the whole thing is only by lime plastering. Now this is the brick which floats on water. The normal brick has a density of 2.2 and its strength is about 25 kg per centimeter square. About 20 to 25 kg per centimeter square. This brick is less than 1, 0.85 to 0.9. And its strength, bearing capacity is 40 to 50 kg per centimeter square. It takes double the strength, less than half the density. So why the Kakatiyas have done this exercise? So presumably they must have felt by going in for the normal brick, there will be a very heavy load on the Sikara and there is going to be a settlement and the structure will fail. So that it must have been their vision. So this is why I wrote in our dossier criteria. We have to give criteria. Criteria number 1, creative genius of those sculptors. Creative genius. So this is the real creative genius of the people who have created a floating brick with very high porosity, with very low permeability. It's like a pumice. You know, when you have a volcanic flow, the froth gets consolidated, and that is the pumice. So pumice floats on water. It has a very high strength. So they have created such an excellent brick which floats on water, which takes double the strength. So had they gone in for normal brick, the whole structure would have collapsed long back. It would have gone definitely settlement phenomenon, which we will see. And we have presumed that they must have used the normal clay from a tank bed. Then normally we add rice husk, jute. In addition, they must have added gum karya, gum. You know, gum is available in the forest. Now, this gum in large quantities, Girijan corporations, they sell gum in tons and tons, hundreds of tons. So they are available in forest. So they must have, this is a resin, it's an organic resin. So they must have mixed that gum karya along with this material and burnt it at a particular temperature where the gum, being a resin, gets volatilized, leaving behind a large number of holes like a honeycomb structure without interconnections. Presumably, we have not done any experiment. This is one of my presumptions. That's how they must have used this wonderful brick. And this brick, in fact, I should have brought the brick at the 11th hour. It could not happen. I have done this exercise in Delhi about a month back. So we went there to receive the letter of intent, and I gave a talk to them. And I said, I'll show you a small experiment. So I took 2 glasses of water and the 2 bricks, normal brick and the brick of the Ramappa temple. So I put 1 glass, the normal brick, immediately it sank. Then I put the Ramappa brick, it was floating. It was such an exciting phenomena for all those people. They were astonished to see such a brick exist. I said that is the reason why we have taken this forward to enter into the World Heritage Site. So this is Nandi Mandapam, which has collapsed, and we have recreated it similarly. So the Nandi used to be inside the temple. So this is another great Nandi, and this Nandi is again made out of a black dolerite, which is not available there. The local available rock is only sandstone. So they have used the sandstone in all the places, but wherever there is going to be a very heavy concentrated loads, they have gone in for granite, and still higher concentrations of loads, they have gone in for black dolerite. So this is the, again, Sasana. Now you could see the settlement phenomenon. You can see these two be together, there is a settlement. Now again settlement at this corner, settlement there. Now this is Kakshasana. Now we are entering into the floor level. Now this is the floor level and the central dancing place. This is the central dancing place. Now if you can see the beams. This is one huge beam at the floor level and it is broken into two pieces and there is a settlement of all the four columns. You can see the upliftment. The upliftment is more than 10 to 12 inches, such a differential settlement. In spite of such huge failure and fracture and settlement, structure is still intact. Now that is their great ingenuity. So this is what the great ingenuity is. The factor of safety which they have taken into consideration is so high that in spite of such a failure of the floor beams, still the structure is intact. So this is how we have represented to the UNESCO. Now these are the bracket figures which we will show you. Now you can see the Nagini. This is in fine, exuberant black granite with mirror-like polish. So this is the rock cantilever. The rock cantilever is supported by a bracket, and the bracket is decorated with Naginis. Now it's various types of, see the level of carving, and you see the monkey is trying to, not monkey, a girl is trying to remove the thorn in the leg. Now here you will see one of the beautiful aesthetic figure. The monkey is trying to pull the sari and the lady is trying to protect her chastity by putting a hand. No, they have broken the hand. Trying to protect her chastity by protecting it. So this is a mythological phenomena. You can imagine to any level of mythology and the ego, the intricate, inner feelings of the so-called the ladies, how they react under different circumstances. Now this is another figure. So this is the cavity wall of the Ramappa. Now there are other small shrines around. They are all small things. So you can see the level of settlement. Now we have to remove and rebuild. Otherwise you cannot do anything except. So we are trying to, we have removed this. They are all numbered. And so before the commencement of the removal, we have a Bhumi Puja there. See how carefully we remove layer by layer. So this is, you can see very clearly here, we have removed the whole temple. And this is the central piece. And this is the sand. You're able to see the sand very clearly because we have removed the whole, just like what we have seen in Thousand Pillar Temple. Here, Ramappa Temple, we have removed one sub-shrine and you are able to see the sand very clearly. So this is one of our director conservation. This is our Stapati. So this entrance was broken, we have restored it, before and after. So let us protect and preserve our heritage for posterity. So this is how we are trying to do our bit in trying to restore our monuments so that our posterity will really enjoy how the great Kakatiyas have done and what we could do a bit in protecting and preserving this great heritage.
I wish this video is preserved also. Yes. For the posterity to see. It should be.
It's only because of our Honorable Padma Bhushan Nagaswamy garu.
No,
I am able to come here and share some of the things. I am really beholden to him. I am really indebted to him.
But for him, we would have reached a brilliant presentation.
So this is a great honor for me that I am able to do it with the gracious, acceptance of our Nagaswamy garu and our Ramakrishna garu, who is really benevolent. I call Kakatiyas as benevolent rulers. So there are benevolent people who here who are responsible for creating such a type of wonderful avenues for sharing our thoughts.
And how I wish all the IITs, as Dr. Nagaswamy was referring to, this must be shown. It should be a mandatory.
We will try to do our best, sir. No, see, this is, you will be surprised. The one which I have shown you in about an hour, we are doing it right from 2006. 2006. With so many hurdles, with press biting, with press biting, and the politicians.
Normal people also.
And the press, everybody. And these fellows, I am supposed to be an Andhra. Andhra people Ochi. They are destroying our heritage. I joined in REC in 1962 as a lecturer. So 1962 till today, I am in Warangal. And my contributions are in water resources. In fact, I designed a flood flow canal in 1984 to utilize flood waters. Flood water comes and goes going away. And ultimately joins Bay of Bengal, converting itself from fresh water to saline water. So I have created a flood flow canal and a mid-Maneru dam in 1984. P.V. Narasimha, he was very close to me. He calls me as Pandu, come here. So I made a three-dimensional model with the help of my final year BTech students in 1984, Silver Jubilee of 1984. Then he rang up to me, Panda, I am coming to your department. Why, sir? I want to see your model. Now that model is now reality.
Oh, I see.
Now that model is a reality, 100% they are now executing it. So in water resources, in archaeological conservation, we have been doing. At that time, Andhra varu velochi paadu chestunaru. They are spoiling the whole.
Warangal has state money.
Telangana, now it's in Telangana. Now it's in Telangana. So the whole problem because of the bifurcation. So now we are happy. Everybody is happy.
What is the situation of that 1,000 pillar now? Is it fully over or something?
Now we have come to the roof level. And we have done reasonably good work. And due to some small technical and financial and administrative problems, I met the Director General when I received this letter of intent for Ramappa temple about a month ago, and I invited her to come to Warangal, and I have explained to her about the various small bottlenecks here and there, and she promised she would come very shortly, and our people are also there. In fact, yesterday there was discussion on Ancient Monuments Act. And all monuments will have a restricted zone, prohibited zone of 100 meters and a restricted zone of 200 meters. So one of my friend, the MP in the Rajya Sabha, so he is going to answer those questions. He wanted me to send an SMS about what he should talk. I'll read what I said. Last night in the train, I made this.
Somebody is there to represent you, sir.
but difficult to implement. Lots of encroachments.
So he is now talking on amendments to the Restoration Act of 1958. Amendments. The idea is for every monument you have 100-meter prohibited zone. Nothing should come out in that 100 meters around the monument. And from there, 200 meters is the restricted zone. So with permission from competent authority, you can build structures. That too with a level. Now, the government of India wants to do an amendment to the prohibited zone. So my friend, the Rajya Sabha MP, he was one of my old friends, young boy. He wanted me to give a information for presentation. I gave this last night in the train. The prohibited zone of 100 meters fixed around the monument is meant for creating less interference by various activities to the monument. However, in some places, the vibrations created due to man-made static and dynamic disturbances can create enormous stress to the monument. One such example is Ramappa temple, where an underground tunnel is being executed involving heavy blasting at a distance of about 200 meters approximately. This is going to create enormous damage to the temple, and hence it was forcefully stopped to save the monument from differential settlement as it was built on a sandbox. Similar instances may occur elsewhere. In order to give facelift to the monuments, many structures in close proximity may hinder the grandeur of the monument. Keeping such instances in mind, it's very essential to maintain 100 meters prohibited zone strictly without deviations. Professor Pandurangarao, retired professor from NIIT. So this is what I gave it to my friend for a presentation. There are so many amendments which they are trying to do, but 100 meters prohibited zone shall never be encroached upon. If we do that, there will be so many problems. We heard that some railway line is to go, some highway is to go, and there will be so many things. The moment such actions take place, the so-called vibrations, you will be surprised. Devadala is a big lift irrigation scheme in Telangana. We are lifting water from Godavari, which was a part of it about 20 years back, from 70 meters to 400 meters. So from 70 meters we lift water to 400 meters, huge quantities. And each pump is 15-20 megawatts. Each pump is 15-20 megawatts. It pumps water through a 3-meter dia pipeline. Now you can imagine 3-meter dia pipeline. Now, in that process, there is phase 1, phase 2, phase 3. In phase 3, they are making a tunnel of 6-meter dia, 6-meter underground tunnel. You can imagine how much blasting is required. This is about 200 meters. That's why I gave an example. So I learned these fellows are blasting heavily. I went and saw. Then immediately I stopped the work. Then the engineering chief and then the secretary irrigation, they became so angry with me, and I was a scapegoat. Then I finally said, you can do lots of things, but can you reproduce? Can you protect? If this is destroyed because of vibration, vibration is the most dangerous thing for sandbox. The moment there is a vibration, sand gets consolidated. Whereas for clay and all that, only compaction will be the consolidation. But for sand, vibrations. So, if there are vibrations at a distance of 200 meters, the whole structure will collapse. Then they asked me, what is your alternative? I said, there is very simple. I calculated the discharges from 6-meter dia pipeline, 6-meter dia underground tunnel, and then what pressure and all that. Then I gave them, after 1 week of thorough investigation, you go for 3 rows of 3-meter dia pipeline. 3 rows of each 3 meter. Each 3 meter. 3 rows. Don't change your alignment. Now, I'm happy they have accepted it. Now we have stopped the underground tunnel at Ramappa to save it. So I gave this example to my friend so that such instances will happen and they should be taken care of. So I think...
Any more questions?
any questions? If there are any questions? I'm really thankful to our Dr. Nagaswamy Garu for giving me this opportunity. I'm also thankful to Archaeological Survey of India for giving us an opportunity to work with them. And we are really beholden to all of you for giving an excellent opportunity for me to share our experiences there. Thank you.
Be here. I want to tell you, I studied the Agamas, Saiva Agama and Vaishnava Agama, and both the Agamas, written at least 1,000 years ago, they prescribe that from the outer enclosure wall, 100 meters is also part of the temple. It's also part of the temple, and both inside the prakara and outside the prakara wall, they are all called marmasthanas. You are not supposed to touch any of it according to the Agamas. And you see what an amount of scientific calculation, drawing, and you cannot do it all of a sudden like magic and so on. So, sir, our friends in Tamil Nadu, they did a beautiful thing. You have taken on so many years drawing, etc. Why do all this? Bring one bulldoze. In 2 days, the whole thing thrown out. In near Coimbatore, many such bulldoze temples, full Chola temples, bulldozed in 2 days. He said, how can it happen in 2 days? The executive officer said, I don't know how it happened. It is only the priest who could have removed it. So we found the priest, for those 2 days, he was not there. He was somewhere in Coimbatore in a hospital. So they demolished the whole thing from base to top with the bulldozer and then used 1:10, 1 part of cement and 10 parts of sand, useless sand, that to our beach sand, and build a new one. And we have grants in crores and crores. We told them, you leave it. Why not you leave it? You don't do anything. Somebody will come, establish laboratories, scientific laboratories, and people like him to train a generation of conservators in the whole country. And for 5 years, you must not touch any of these temples. I sent a note to the Chief Justice of Madras High Court, and he incorporated it in that and said that do not touch any ancient temple unless it is in a very bad state of preservation and going to collapse. Otherwise, you wait for a generation of conservation engineers, specially trained, and also laboratories testing each and everything. Every aspect has been tested like that brick. Unless we do that, we cannot, and the judge has ordered it. So what our people thought, unfortunately that judge has been sent to New Delhi. As one of the Chief Justice of India is there. So here, they bundled all these orders and threw them out, and like the whole other things, they again started doing bulldozing. Where are we? Science has progressed so much, and you compare it, there is no difference between ancient agamic prescription, which are all experiences documented there, as he said, in technology, or the Kakatiyas have done such technological progress. Why not benefit by the old agama And also the new science, there is no absolutely conflict between, and when you read, they read the ancient technology also and give our help, but nobody cares here. And nearly 2,000 temples have been already affected in Tamil. And it is a very sad thing, but that's why I am extremely thankful to you that you must travel all over India and tell them, please do not touch any of our ancient monuments. They will remain. They are all stone. Until we have experts who can handle it, we should not allow them. There must be enough public response. Otherwise, what they think is, 2 crores of renovation, great renovation is going on. What are the renovations they do? Already existing stone flooring, they bulldoze it and take it out and put another inferior tiles over that. What type of renovation? So I am very happy and thankful to you for having come here, and I hope we will carry this message to all our people. Thank you very much.
I want to present to you our Nitya Ratnavali book.
Sir, 1 second, sir. Sorry, sir. See, you already see. No, you listen. Sir,
Please come and
through you only I am going to tell. Near Mahabalipuram World Heritage Monument, near the Arjuna's Penance and the Krishna Mandap and 5 Rathas, lots of buses, coaches, cars, they go. Please put a suggestion to your Rajya Sabha member. Let not the coaches or cars should go right in front of those ASA monuments.
Yes.
What is it,
I'll give you. I'll tell you that.
we can't say anything because we said there was one man who sat down by the side and he was selling ticket for people to go. They are making money out of it. And I have seen it 50 years ago. Nothing was there. Nothing was allowed to go in. But now all petty shops, all type of hundreds of lorries and big buses going in front of that Arjuna's Penance. What a silly thing that is happening. And every inch has been given out for petty shops.
Yes.
You know that?
Yes, sir.
So nothing can be done here.
Put your word.
Luckily, somebody was trying to restore, and you read what happened this morning, One of the topmost officers of the HRNC department is inside. They are going to, but nothing is going to happen. It will continue because we are Dravida. Thank you very much.
Sir, this is a book, Nitya Ratnavali, written by the Commander-in-Chief of Elephant Army of Kakatiyas about 1,000 years back in Sanskrit. And the whole book was translated into English and transliteration by our Pappu Venugopal Rao Garu and Dr. Yashoda. So I have the honor to present this to our...
Thank you so much. Thank you so much.
Similarly, this is done by our Kakatiya Heritage Trust.
Oh, I see.
This is done by Kakatiya Heritage Trust. We released the book in Delhi and also in Madras, where my friend Mr. P.K. Doraswamy has come to witness that. So this is another book which we have done. This is all done by a great the Kakatiya Heritage Trust. This is an international, both are international publications. I wish Ramakrishna Garu to come and accept this on behalf of all our friends. So this is a book which we have spent 50 lakhs. This has costed us 50 lakhs. And fortunately, all the money had come from one of my old students.
Oh, so nice. For good work, there are people. Thank you so much.
And here, I want to show you one picture of our 1,000 pillar temple.
Won't get many.
Right. Now you could see the beams, the roof beams, which we missed. Roof beams. You can see these are huge beams. Each beam will weigh about 8 to 10 tons. Now they are broken into 2 pieces. Now we have mended it by inserting
Ever silver.
30 stainless steel, 30 this much, 30 stainless steel rods, and then we have gone in for stainless steel dowels with epoxy resin, and then we'll take this and put it on the roof level. We don't want even a small piece of that to disappear, to be lost. So this is how we are doing, and this is you can see the dowels which I have showed you. So this is the present level of Kalyana Mandapam. So I am there. I thought I should be there.
Definitely.
So these are the various great Kakatiya structures, a pictorial representation, a very beautiful book. So this is the sandbox. You can see the sand beneath the things. At Ramappa, near Ramappa temple. So this is the
Thank you.
I think it has created so much of interest, nobody wants to go, and I only feel that he has stopped it. Should have gone a little longer. So much he has said. Sir, we are very happy. One of the finest lectures that have taken place here, and this is called the real restoration of work, I think. This is the first time probably I am seeing a restoration work. Thank you, Rao Garu, for coming all the way and telling us. Thank you.
once again, everybody, let God bless all of us for restoring this. I hope you have enjoyed.